Hydropower generation plants. Motion of water in hydropower plants is applied to generate electricity. When moving water with kinetic energy collides with the dam's turbine, the water's kinetic energy is converted to mechanical energy. This mechanical energy drives the turbines, which produces electrical energy in the end. Windmill plants. Windmills are an excellent illustration of kinetic energy applications. Wind striking on the windmill blades causes them to rotate, resulting in the generation of energy. The motion of the air molecules develops kinetic energy, which rotates the blade and gets transformed into mechanical energy. Moving car. Kinetic energy is present in moving automobiles owing to their mass and velocity. A moving vehicle of a larger size will have more kinetic energy than the one with a smaller mass, because mass of the moving object is a proportional factor in the formula of kinetic energy. Bullets fired from a gun. Bullets fired from a gun also establishes kinetic energy, which drives its motion at a high velocity. Because a bullet fired from a gun has so enormous kinetic energy, it may easily pierce any object. This giant energy value is attributed to its very high velocity upon being fired from the gun. Although the bullet has a lower mass, its fast speed generates twice as much kinetic energy. Flying aircraft. Airplanes demonstrate kinetic energy during the flights. A flying airplane has a lot of kinetic energy since it not only has a lot of mass, but it also has a lot of velocity. When the airplane is flying, both of these statistics result in increased kinetic energy and facilitates it to soar up in the sky. Riding bicycle. Kinetic energy is present in moving bicycles. The mechanism is that when we begin pedaling, we are transferring our body's energy into mechanical form, which is initially potential energy and is eventually converted into kinetic energy owing to the wheels. Motion. Increase in velocity causes the kinetic energy to increase as well, which can be returned to zero only by applying brakes opposite to the direction of the force and causing the vehicle to decelerate until it comes to rest. Walking and running. We have some quantity of kinetic energy when we walk or run. This explains why we feel warm after running or walking a short distance. Chemical energy of the human body is converted into kinetic energy, which in turn generates sweat owing to the heat produced during the activity. Roller coasters. Roller coasters are adventurous rides, but what happens to the wagon during a free fall? At the topmost position of the roller coaster, the wagon is at rest and thus it has zero kinetic energy. However, allowing it to fall freely results in a progressive rise in kinetic energy as the wagon's speed increases. More number of people on the ride will increase the overall mass, thereby uplifting the value of the kinetic energy, provided it moves at a steady rate. Cricket ball. Throwing of a cricket ball is a classic example of kinetic energy application. The cricket balls at rest in the hands of the bowler has no kinetic energy. The sooner the ball is thrown towards the batsman, the mass and the velocity gained by the ball start generating kinetic energy that keeps driving its motion. This tremendous amount of kinetic energy can be injurious to the players and hence wearing of protective gears is necessary. Skateboarding. A person riding a skateboard also witnesses kinetic energy during the activity. The skateboard at a rest position has no kinetic energy. Once it starts moving forward with the wheels rolling, the kinetic energy increases gradually. The weight of the rider adds to this kinetic energy even more as mass if the object is a multiplying factor in the formula of the kinetic energy. Dropping an object on the ground. What happens when we accidentally drop an object on the ground? The object is devoid of any kinetic energy whatsoever at its topmost position, where it consists of only potential energy. When it starts falling under the gravitational effect, it acquires an acceleration, and the potential energy keeps getting converted into kinetic energy. Kinetic energy reaches its maximum value right before the object touches the ground, which is then released upon its breakage. Movement of vehicle on hills. Vehicular movement on hilly roads also displays the establishment of kinetic energy. The height causes any vehicle to have more potential energy and nearly no coefficient of kinetic energy. This potential energy keeps decreasing with the descent of the vehicle down the slope, while the velocity causes the kinetic energy to increase. The kinetic energy of the vehicle reaches its maximum value at the bottom of the hill, while the potential energy will be zero, given the vehicle is moving at an unaccelerated speed. Meteor shower. Despite the fact that meteor shower is not a typical example of kinetic energy, it is a fascinating event that occurs in the solar system. Our solar system has meteoroids dispersed all around it, and they are drawn to the Earth's atmosphere by gravity. This results in the free fall of these meteoroids at an immense rate, with considerable amount of kinetic energy owing to their massive size and weight. The collision between them and the surface of the Earth creates an explosion due to this significant amount of kinetic energy. There are few examples that witness application of kinetic energy in conceptual ideas. Kinetic-powered phone. The Kyocera EOS is a conceptual kinetic-powered phone in its early stages of development. This phone can be used both in a folded manner and by exposure of a significantly larger screen. An array of piezoelectric generators is fitted in order to convert the kinetic energy produced by human touch into significant electric charge. The fear of carrying an uncharged or a partially charged phone won't be a reality anymore. Kinetic energy lamp. The Crank, a lightweight lamp driven by hand, was created as part of the 2008 Greener Gadgets design competition, which yielded a number of eco-friendly, inventive inventions. The Crank was designed by Efren E. Beless in the United States, and is inspired by the look and function of an old-fashioned mechanical drill. It has a 100% recyclable aluminium body. Hand-powered cranking provides roughly an hour of light in about a minute. Kinetic-powered floor cleaner. Ms. Neo Amy submitted the concept of a kinetically powers floor cleaner to the Australian Design Award. It was named Electrolysis, and it was based on the similarly conceptualized human-powered design. It is significantly aesthetic in its appearance, much more user-friendly, and also easier to empty. Kinetic-powered snack cooler. A snowplow has been designed that utilizes kinetic energy for operation. The kinetic energy-driven snack cooler has been designed by Aper PSP Key as a fashionable bag with a built-in chilling unit and plenty of space for water, lunch and snacks. The handle is meant to rotate with movement, capturing and utilizing the energy generated by walking to keep items cool. Pedal-powered snow plow. A snow plow has been designed that utilizes kinetic energy for operation. Kevin Blake is a bicycle designer who came up with an amazing green alternative to a standard gas-powered snow blower. He gathered an old lawnmower, some pedals, and a snow shovel and turned his conceptual idea into reality. Pedaling generates kinetic energy, which eventually drives this machine. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.